Now we come to the next part, which is finding term independent of a variable in a binomial expansion. Okay, I'll just simply show it. See, try to understand. If I say what is the term independent of x, let me put it in the beginning itself. We are trying to find independent of x. Term independent of x. In the expansion of, let's say, x plus y to the power n. We have seen the definitions that all the terms will have some power of x present in them, right? Except the last term. So here the term independent of x is only y to the power n. I hope you're getting it. So in such situations, there is no problem at all. There is no confusion at all. So whether it is ax plus by to the power n or anything for that matter, ax minus by to the power n, or if it is 2 by 3 minus 7x to the power, let's say this is 20 and this is 13, very easily we can find the terms independent of x. In this, the term independent of x will be only the last term, that is by to the power n. In this, the term independent of x will be minus by to the power 20. Am I right? Now this one, you can also put 20c 20 here. You can also put nc n here. In this, the first term will be the term independent of x. Can you see 7x? X is present in the second part. So when you expand, this becomes the first part. This becomes the second part. So here this is 2 by 3. So only the first term, 13c0 into 2 by 3 to the power 13. Only this will be term independent of x because the next term will have x to the power 1. So these are the terms independent of x in these situations. But in the exam, you will not get these questions. The question that you will get in the exam will have only one variable, let's say x, but in different degrees. For example, if I want you to find term independent of x, say the question is the same, term independent of x in the expansion of, let's say 2x minus 3 by x to the power 8, something like this. Now, how do we go about it? Now, there is one very simple shortcut and you can simply go ahead and do that. But before that, let's try to understand this. First, let's talk about the shortcut process for this. I mean, it is not a shortcut, it is logical, so I will not use the word shortcut. Let's see. Look at the degree of x in the numerator and look at the degree of x wherever it is present in denominator. So degree is 1:1. The ratio of degrees is 1:1. I repeat, this is the degree of x, power of x in the where it is present in numerator, and this is the power of x where it is present in denominator. So don't take -1. I'm saying already in denominator whatever is the power, right? So ratio is 1:1. Oh, can we divide this 8 in the ratio 1:1? Yes. So divide it. So 8 when you divide in the ratio 1:1, 4:4, right? This gives you the value of r. What does that mean? R equal to 4 means fifth term. Oh, great. Fifth term will be the answer, will be the term independent of x. How and why we'll explain in a little while, but first try to understand the process. Okay, so fifth term, and that would mean 8c4 into 2x to the power 8 minus 4 is 4 into minus 3 by x to the power 4. You'll see that x and x will get cancelled and your answer will be 8c4 into 2 to the power 4 into minus 3 to the power 4 is eventually 3 to the power 4. So this is the term independent of x and it is the fifth term in this expansion. I'll give you one more example. 3x square minus 5 by x to the power 12. So can you find the term independent of x? Yes. Let's see. Degree of x in the term where it is in numerator 2. Degree of x where it is in the denominator 1. The ratio 2:1. Can you divide the given power in this ratio 2:1? So 12 divided in the ratio 2:1, it will be 8:4. So this is the value of r, right? R equal to 8. So ninth term will be, so question there'll be many questions. Question can be, which term is independent of x? Ninth term. What is the term independent of x? Then you need to calculate. So ninth term is r equal to 8 and the value will be 12c8 into 3x square to the power 12 minus 8 is 4 into minus 5 by x to the power 8. Now you can see that here x square to the power 4 will be x to the power 8. And here x to the power 8 and it will get cancelled. Oh, great. So that also means that it is not necessary that an expansion will have a term independent of x, right? Sometimes it may not have also. I'll show you an example. 12c8. So the answer of this question will be 12c8 into 3 to the power 4 into, coincidentally here also minus 5 to the power even power, so it becomes positive. It could be negative also. Just be careful in simplifying. After this it is only simplifying. Whatever is the correct answer, you need to get to that. So this is the shorter process. If I give you a couple of more examples, say for example, find the term independent of x in the expansion of 3x to the power 4 minus or plus 7 by x to the power 5 whole to the power 20. Look at the ratio of powers, 4:5. Can we divide 20 in the ratio 4:5? No. So what does it mean? No term independent of x is possible. No term independent of x is possible. I think you have to understand this very, very clearly, right? I hope it is very clear. If it was something like 3x to the power 4 plus 7 by x to the power 6 to the power 5, can we have a term independent of x in this? Check the ratio, 4:6. 4:6 is 2:3. Can you divide 5 in the ratio 2:3? Yes, of course, right? So 5, 2 and 3. So r is 2. The first value is the value of r, right? So r equal to 2 means the third term, and the third term will be independent of x, and that will be, now I'm going to write the answer directly because I know x will be cancelled. So I'll only take the coefficients and values. So 5 C2 into 3 to the power 3, 5 minus 2 into 7 to the power 2. So I hope, by now it is absolutely clear that sometimes it is not possible and sometimes it is possible also. There is a theoretical explanation to this also. I'll take this example and I'll explain. If I randomly take r plus 1th term, what do I get? I get 5cr, right, into 3x to the power 4 to the power 5 minus r into 7 by x to the power 6 to the power r. Now bring all the numbers on one side or together, 5cr into 3 to the power 5 minus r into 7 to the power r. So this is the coefficient. Into combine all the powers of x. Can you see the power of x here will be x to the power 20 minus 4r. Okay. And here it is x to the power 6r. So it goes to the numerator like this, minus 6r. You see, if I want the term to be independent of x, then this power of x should be 0. So 20 minus 10r should be equal to 0. So r is equal to 2. All right, so this is the method. So what is important here? I'll take only one example like this. Otherwise, we'll always use this process. Okay. So for term independent of x, term independent of x, what do we have to do? Simply take the r plus 1th term or the general term. We have been calling it general term, right? Okay, and equate total power of x. Remember, total power of x to 0. And you will get the required value of r from there, right? So one example is sufficient for that. And suppose in the previous case here, if you had done it, I would directly show it to you. X to the power 4 to the power 20 minus r. X to the power 4 to the power 20. So 80 minus 4r and minus 5r, right? So if you simplify this, the total power is 80 minus 9r. So 80 minus 9r is equal to 0. R would be 80 by 9. What does that mean? This is not integer. A position cannot be fraction. Position has to be integer. And that is why there was no term independent of x possible in that case. So you could check all the 4 or 5 previous examples that we have just done, right?